This is my Kinematics Reassessment, and this is a problem. An archer shoots an arrow at a 22-degree angle to the horizontal. At the top of its motion, the arrow just clears a 36-meter high oak tree. How fast was the arrow going when it left the bow? Assume that it was shot from a height of 1 meter above the ground, and how far away is the archer from the tree? Now, I started out by drawing my picture. The archer, the tree, the arrow being shot at a 22-degree angle. It was above 1 meter from the ground. The tree was 36 meters high, and it wanted the initial velocity that it was shot with, the speed, and it also wanted how far the archer was from the tree. So I wrote down my knowns, or my givens, and the acceleration in the y direction and acceleration in the x direction. Acceleration in the y direction is negative 9.8 meters per second, whereas in the x direction it's 0. This is the initial x velocity, and this is the initial y velocity. And we have the initial velocity times the x component and the y component, and then this is the final velocity in the x direction, which is the same thing, and then the final velocity in the y direction, which is 0. This is the original x position, which is 0, the original y position, which is 1 meter, the final x position, which is what we're looking for, and then the final y position, which was 36 meters. So to start out, we're going to use this formula. It's one of the kinematic formulas that we can use, and we know the v squared, or we know the final velocity in the y direction, initial velocity in the y direction, we know the acceleration in the y direction, and we know 2, and we know our change in y. So we're solving for the initial velocity here, and when we plug everything in, we multiply here, this comes out to be a negative, we move it to the other side, which we're given here, and then we square this take the square root of this and square root of that because this is squared, and then we divide by sine of 22 degrees, and we're given 70 meters per second, and 70 meters per second is how fast the arrow leaves the bow, the speed, the initial velocity. So then after that we come down here and we use this equation to find the time, because we're given our initial velocity in the y direction, final velocity in the y direction, acceleration in the y direction, and we don't know delta t. So we plug in what we know, 70 sine of 22 degrees plus a negative 9.8 times delta t, and that gives us 9.8 delta t is equal to 26.2 meters per second. Divide by 9.8, and we're given 2.67 seconds as our change in time. And I got a positive 9.8 by moving this to the other side to take place at 0. So now that we have our change in time, we can solve for the final x position, which is given to us by this equation. The final x position is equal to the initial x position plus the initial velocity in the x direction times the change in time plus 1/2 acceleration in the x direction times the change in time squared. And since our acceleration in the x direction is 0, that just becomes 0, and this doesn't even matter. So then all we're left with is this. The final x position is equal to the initial x position plus the initial x velocity times delta t. And so from there we can get the final x position is equal to 0, the initial x position, which we knew here, 70, the initial x velocity with the cosine of 22 degrees, and then our change in time, 2.67 seconds, and that gives us 170 meters, so that is the length from our shooter to our tree.